Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners. Welcome to today's natural sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are still on the strand energy and change for our term 3, right? Which contributes about 80 marks for your exams. And we're still talking about electricity. So the topic for today is the cost of electrical power. And we'll be looking more specifically on the cost of power. So stay tuned. Let's look at the lesson objectives. This is what we need to achieve by the end of this lesson. So meaning by the end of this lesson, you should be in a position where you can be able to define electrical power as the rate at which electrical energy is supplied. By the end of this lesson, that's point number 1 that you should have achieved, right? Being able to define electric power as the rate at which electrical energy is supplied. Secondly, you should be able to state that electrical power is measured in units called watts or kilowatts. And thirdly, you should be in a position where you are able to explain that all electrical appliances use electrical power to work. Also, you should be able to explain that the power rating of appliances can be determined by looking at the back panel of the appliance. Also, you should be in a position where you are able to state that 1 watt of power is equal to 1 joule of energy supplied in a second. Not only that, right? You need to also be able to explain that consumers pay for the quantity or amount of power they use. And lastly, you should be able to explain how to calculate the cost of electrical power used. And all this information is found under the KEPS document on page 76. Now, let's move on to what we have done before, right? To what we have done in the previous grades and also the same grade prior to today's lesson. So in grade 7, starting with grade 6, in grade 6, we have introduced mains electricity, right? We have introduced mains electricity. Then later on in grade 7, we spoke about the supply system. Then later on in grade 8, we did the energy transfer in electrical systems. Then in grade 9, we did also some interesting topics such as the national electricity, electric cells, and also series and parallel circuits. This is all that we need as foundation to today's lesson. Now, let's look at this baseline activity here, right? It has 4 questions, so it means I'm going to give you 4 minutes to answer these questions. But firstly, let's go through the questions together. Number 1, it is saying, what is electrical power? Then number 2, what is a power rating? Number 3, what is the unit of measurement for electrical power? Number 4, why do we need to know the cost of electrical power? That's all that you need to do for your baseline activity. So take 4 minutes of your time, then after that, we may be able to continue together. Welcome back, grade 9 learners. Are you winning with those answers? I hope so, right? Now, number one, let's look at the solutions. Number one is saying, what is electrical power, right? And electrical power is what? It is the rate at which electrical energy is supplied. Supplied where? Supplied to an electric device or an appliance. Are we together? Mark your work. Number two, what is a power rating? A power rating, it is electrical power an appliance needs in order to work. Mark your work. Then number three, what is the unit of measurement for electrical power? It is measured in watts or kilowatts, right? Then number four, why do we need to know the cost of electrical power? This is the reason. So that they can know how much money it costs to run various household appliances and save our electricity by using it wisely. That is the reason why, right? So that we know how much we used and how much we need to pay for it. So now let's just take a quick minute to copy down the corrections.
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Welcome back, grade 9s. Now, I hope you had ample time to copy down the corrections, right? Let's move on. Now, let's look at the important terms that are associated with this lesson, right? First of all, we have electrical power. What is this electrical power that we're talking about here? Electrical power is the rate at which electrical energy is supplied to an electrical device or an appliance, right? Then secondly, we have watt. And watt is the unit of measurement of power. We also have power rating. And power rating is electrical power an appliance needs in order to work. We also have what? We also have kilowatt hour. And kilowatt hour is the measure of the quantity of electrical power used. We also have unit price of electricity. And that is the cost of electricity in rands or cents per kilowatt hour. Then we have what? Tariff, which is a schedule of prices or fees used to charge for services. Right, now let's get on to today's main meal. We're talking about electrical power, right? So now, before we continue so much, I want us now to talk about power. We said that power is the rate at which work can be done, right? So now I want you to imagine two cars. Yes, cars, they do the same job, right? To move, right? So what is the difference between these two cars now? They are both climbing up a hill, but one car is able to climb up the hill effortlessly, and the other one, yes, it is trying, but it is struggling to climb up the hill. So meaning, what is the difference? The power in these two cars is different, right? So that's what we're going to talk about mostly today, right? That most electrical appliances are different, and hence they use what? Different amounts of power. So we said that electrical power is the rate at which electricity is supplied to an electric device and also an appliance, right? It is the rate or the speed at which it is supplied to a certain electrical device or appliance. So electrical power is the amount of electrical current that is flowing through a system as a result of voltage. And also remember this. Remember that current is the rate at which electrons flow through a conductor. So now, also, voltage is the force with which electrons are pushed through a conductor. So electrical power is measured in units called what? Watts or kilowatts. Right? So let's not forget that electrical power, it is our rate in which this electrical energy is supplied into an electrical device or an appliance. So that electrical power, it is measured in units called watts or kilowatts. So this unit of measurement indicates how much electrical energy is being used per second by an appliance, by a device, by your laptop, by a stove, by a geyser, and so on, right? So it indicates how much electricity has been used per second. Are we together? So it means what? For example, a 100-watt light bulb will use a lot more energy, more than what? A 20-watt light bulb, right? This is because the energy it can consume, it is higher than the one of 20 watts. So it uses more power to do its job, right? Which is to give us light. So compared to the two, the 100-watt bulb will shine brighter because it uses more power, and also it will consume more electricity because it does what? It uses more power. And as for the 20 watts light bulb, it will also consume electricity, but at a lower rate because it can only use what? 20 watts of electrical power. Are we together? So all electrical appliances use electrical power to work. Moving on. So the power rating of appliances can be determined by looking at the back panel of the appliance, right? Now let's think of a kettle for an example, right? A kettle is an appliance we use at home to boil water in most cases, right? We use it to boil water. And we're saying that the power rating of appliances can be determined by looking at the back panel of the appliance. So here is a back panel of this appliance, the kettle, right? It has some information there. It has the model, it has the name of the brand, it has the model number, and also it has the what? The amount of volts in which this appliance can use, right? Now, if you look at this here, the model number is 13882. Now you have what? 220 to 220 volts, then 50 or 60 hertz. And also what we're looking for now here, the watts, right? It is 2,520 to 3,000 watts, right? That is the amount of electrical power it uses. So it means what? If an appliance uses a lot of electricity, then we measure the power consumption in thousands of watts or kilowatts. And we're going to talk more about that. Now, consumers pay for the power they use, right? So often at home they say, go and buy electricity, and they give you, or they write you down what? A meter number. Go and buy electricity. Oh, here's an electricity bill. So on and so on, right? This is because we pay for the amount of power we use. So while a household appliance is working, it will be using electricity at a certain rate, right? As we are boiling water then, as you are turning on that geyser, as you are cooking on that stove, it is using electrical power at a certain rate, which is measured in watts. Are we together? All appliances are using electricity at a certain rate, which is measured in watts. So now to calculate how much that costs, we measure how many watts are used over a period of 1 hour. Over a period of 1 hour, we measure how many watts are being used by each and every appliance in the house over an hour, right? So we call this what? A kilowatt hour. And it has the symbol kWh, right? So we call this a kilowatt hour. This is the measurement of what? Of the electrical power used in 1 hour. So this means that if you run an appliance rated at 1,000 watts or 1 kilowatt for 1 hour, then you will have used what? 1 kilowatt hour of electricity. Are we together? Now, let's measure this electrical power that we're talking about, right? So to emphasize this, we said that electrical power is measured in units called watts or kilowatts, right? And 1,000 watts is equal to 1 kilowatt. So what do we need to get what? The number of watts or vice versa. So we divide or multiply by 1,000, right? Some components are written in watts and some components are written in kilowatts. So to try and look for the differences, the number here is what? Is 1,000. So 1,000 watts is equals to 1 kilowatt. So meaning to get a kilowatt, we divide the amount of watts by 1,000 rand. Not 1,000 rand, sorry, by 1,000, right? So if we need what? To get watts, it means we'll multiply by 1,000 to get from kilowatts to get a watt. So for example here, right, a geyser having the following information, right? So we need to convert the watts to kilowatts. Here is our geyser. We are familiar with a geyser, right? And a geyser is a component that we use to store heated water, right? So here is the information. The equipment, yes, it is a geyser and the brand is V-Guard. We have the model and the capacity is 6 liters. And also we have the rated power at 3,000 watts, right? So the rated power here is 3,000 watts. That's what we need to use, right? So we need to convert these watts into kilowatts. So remember, I said that to convert from watts to kilowatts, you divide by 1,000. So 1,000 watts is equal to 1 kilowatt, right? So here we have 3,000 watts as our data. So 3,000 watts divide by 1,000 watts per kilowatt. And it gives us what? 3 kilowatts, right? This is what? The electrical power consumption of this geyser. Moving on. Also, we said that 1 watt of power is equals to 1 joule of energy supplied in a second, right? In this format, 1 watt is equals to 1 joule per second. So now, we have spoken so much so far, right? Let's test ourselves using activity 1. So it is having 3 questions, right? It is saying what is electrical power in number 1. Then number 2, it's saying what is the unit of measurement of electrical power. Then number 3, it has a table, right? It says this table shows different ratings in watts, so convert each one to kilowatts. So because you still have to draw a table as well, I'm going to give you 5 minutes for this activity. Now, remember also to send us your answers or comments during this lesson, right? On 079 578 2908. See you again after 5 minutes. Welcome back, grade 9s. Now, I hope it was an easy activity for you guys, right? So remember that we're still waiting for your questions or comments on 079 578 2908. Let's look at the solutions now. Number one is saying, what is electrical power, right? We define electrical power as the rate of electrical energy supply, right? Then number two, what is the unit of measurement of electrical power? It is measured in watts or kilowatts. Then number three, this table shows different ratings in watts. Convert each one to kilowatts, right? Remember, I said that you divide by 1,000, right? So now, the first one, 3,000 divided by 1,000, it's what? It is 3, right? It is 3 kilowatts. Then the second one is 2,200 divided by 8,000, that is 2,2 kilowatts. 1,500 divided by 8,000, and that is 1.5 kilowatts, right? 800 divided by 8,000, that is what? That is 0.8 kilowatts. Then 12,000 divided by 8,000, that is 12 kilowatts, right? So I hope you enjoyed this activity. Now let's just take 2 minutes quickly to copy down the corrections. Welcome back, grade 9s. Now, I hope you had enough time to copy down your corrections, right? Let's move on. So we're still measuring what? Electrical power. So why do we need to measure this electrical power? This is because consumers of electricity pay for the amount they used. So remember from our national grid, right? You have electricity being manufactured or cooked or generated from a power station. It is transmitted to our power lines, our transformers into the households where we use this electricity. After using it, we need to pay for it, right? So consumers pay for the amount of power they have used. So an electric meter is a tool that is used to record how much electricity you have used so that the company that is supplying electricity can charge you the necessary costs, right? So if you look at your home, you have a meter almost the same like this one, right? It is counting now all the amounts of electrical power that you have used for that month, right? So it is counting here so that the provider can be able to charge you the necessary costs and you pay as a consumer for electricity. Now, also, the quantity of electrical power used is measured in kilowatts. We need to stress that part, right? So that you remember, even during your exam, that it is measured in kilowatt hour, right? That is the quantity of electrical power used, right? So we can calculate the quantity of electrical power used by multiplying the power rating of the appliance by the number of hours it was used for, right? So electrical power in this formula, electrical power used, it is equals to power rating multiplied by the number of hours used. By power rating, we mean the number of watts or kilowatts, right? We mean the number of watts or kilowatts. Are we together? So if we say that it was used for, or it has a power rating of 5 kilowatts and it was used for 5 hours. So it means it's going to be 5 kilowatts multiplied by 5 hours to give us what? The kilowatts hour, right? Are we together? Moving on. The cost of electrical power. So we can calculate the cost of electrical power to the consumer from what? From the meter. From the meter reading, seeing how much they have used, right? So the cost is calculated by multiplying the power rating of the appliance by the number of hours it was in use multiplied by the unit price of electricity, right? So in this formula, the cost is power rating, the number of watts or kilowatts, number of hours used, multiplied by unit cost of electricity. Let's say, for example, right, maybe it is 2 rand per kilowatt hour. So it means here for unit cost of electricity is going to be that 2 rand multiplied by the number of hours used, multiplied by the cost, multiplied by the power rating to get the total cost of electrical power. Are we together? So the unit price of electricity changes every year. And it changes where? It changes on a sliding scale, right? Especially in South Africa. Our electricity unit charges, they work on a sliding scale. So this means that the cost of electricity increases at certain intervals as you use more electricity. And also we can load money on prepaid electricity cards to help us control and understand how much energy we are consuming and how much money we spend on electricity. Now, here is activity 2 here, right? It says copy and complete the table below, just to give you a clue, right? If you look at this table, it has appliances, right? Like television, radio, electrical iron, toaster, kettle, electric carving knife, and slow cooker, right? Then it has the power rating for each of those appliances, right? Power rating for television is 140. So what you have to do is to fill in the blanks, right? So you're going to convert this power rating from watts to kilowatts, right? Then also we have number of hours used per day. So after getting those kilowatts, you multiply by the number of hours. It will give you what? The power used per day for each appliance. So because you have to draw a table as well, let's take quick 5 minutes to write down this activity. Welcome back, grade 9s. Now let's look at the solutions quickly, right? Now we're going to start off with the power rating for kilowatts, right? For television, we divided by 1,000 and we got what? 0.14 kilowatts, right? Then number 2 for radio, from 80 watts, we divided and we got 0.08 kilowatts. Then electric iron, right? We got what? 2.2 kilowatts. A toaster, it is 1.5 kilowatts. Kettle, it is 2.2 kilowatts. Then our electrical carving knife, it is 0.12 kilowatts. Then slow cooker is what? It is 0.32 kilowatts, right? Now let's look at the power used per day, right? So the power used using all the information we got now, it is 0.84 for television, 0.84 kilowatt hour. Radio, it is 0.16 kilowatt hour. And electric iron, it is 1.1 kilowatt hour. Toaster, it is 0.3 kilowatt hour. And for kettle, it is 1.1 kilowatt hour. Then electric carving knife, it is 0.03 kilowatt hour. Then slow cooker is 3.84 kilowatt hour. Now quickly, let's just take a minute to copy down the corrections. Grade 9s, don't forget to send in those WhatsApp questions or comments, right? On 079 578 2908. Now, moving on, right? So we said that to use what prepaid electricity cards, we need to have a prepaid electricity meter, right? So that it keeps on reading the amount of electrical power that you have used, right? So that you are charged correctly. So once a month, households receive an electricity tariff account that states how much their electricity usage has cost for that month. So here is an example of an electricity tariff. Usually an electricity tariff, it has the electricity provider, it has the address of the household, it has the registration number, it has the meter number, and it has all the information that you need to know in terms of how much did they charge you and why did they charge you for that, right? As you can see, for this person, the total amount due is what? It is 1,255.06 cents. Now, also, if you look at this, there's also fixed charges, right? Like network charge, which is R1.88 per day for 28 days, right? Service charge at R2.96 per day for 26 days, right? It has all the necessary information. Now, moving on. As the quantity of power use increases, so does the unit cost, right? So this is a sliding scale. So as the power used increases, also the unit cost increases, right? So a management levy, service charge, network charge, and VAT charges are also added on to the cost of electricity and also written down on that electricity tariff that you receive per month, right? Now moving on. Now let's look at activity 3 quickly. Number 1, It says arrange the appliances in order from those that use the most power to those that use the least power per day. Then number two, which appliance is used for the longest time during the day? Number three, which appliance is used the shortest time during the day? And number four, which appliance do you think costs the most every day given the time that it is used for? So we're using that table that we have written and gotten answers from in that activity too, right? And here's the table alongside. So let's just take about 5 minutes again to copy down and write down the answers. Welcome back, grade 9. Now let's look at the solutions, right? Number 1 was saying arrange the appliances in order from those that use the most power to those that use the least power per day. So here is the order, right? It is slow cooker, followed by electric iron and kettle because they are the same, right? Followed by television, followed by radio, following its toaster, and lastly, it's what? Electric carving knife, right? Then number 2, which appliance is used for the longest time during the day, right? That is the slow cooker, right? Because if you look at this information here, it is used for 12 hours during the day. Then number 3, which appliance is used the shortest time during the day? And that is what? That is the toaster, right? Then number 4, which appliance do you think costs the most every day given the time that it is used for? And that is what? The slow cooker, right? That is the slow cooker. Now, let's move on, right? Let's move on. So now let's summarize what we have learned for today, right? So today we're talking about the cost of electrical power. And we said that electrical power is the rate in which what? Electrical energy is supplied to an electric device or an appliance. Also, we said that electrical power is the amount of electric current that is flowing through a system as a result of voltage. Not only that, right? We talked of what? Electrical power is measured in units called watts or kilowatts, right? We use those units to identify the power that is consumed by a single device or an appliance, right? So the electrical power in which it consumes, it is measured in watts or kilowatts. Also, we said that all electrical appliances use electrical power to work, right? And the power rating of the appliance can be determined by looking at the back panel of the appliance, like the example we gave you of the kettle, right? When you look at the base of it, that's where you find the information, the model number, the model, and also the power rating. So electrical power is measured in units called watts and kilowatts. So 1 watt of power also is equal to 1 joule of energy supplied in a second. Also, we talked about what? Consumers pay for the quantity or amount of power they use, right? So for every amount of power that you have used, you get charged for it and you pay for it. So an electrical meter is the instrument that is used to record all your usage, right? So an electrical meter records how much electricity you have used so that the company that is supplying the electricity can charge you the necessary costs. And we said that the formula that they used is electrical power used is equal to power rating and the number of hours used. And also the unit price of electricity changes every year. For example, in South Africa, our electricity unit charges work on a sliding scale. So we said that we can also load money on prepaid electricity cards to help us control and understand how much energy we are consuming and how much money we spend on electricity. So now, I won't leave you empty-handed, right? I've even given you a homework, right? So I want us to take 3 minutes to copy down this table and this homework. Welcome back, grade 9s. Now I hope you had enough time to copy down your homework, right? So I hope you have enjoyed our 10-2 live lessons, right? So till we meet again next term. So now, thank you, lights out until next term.